Thank you all for attending this event. Thank you so much to the organizers for putting this together. I think it's a very well-run event so far, and I'm excited to see what else we learn this week. So I'm going to go into a little bit of the work we've done in vitro to kind of support what Jose just showed us and the other work that we've seen and we've done so far as to why some of these things might be happening in the rumen system. So Dr. Santos already showed this slide, but a little bit more background of how these minerals were developed. For those of you who don't look at minerals every day like I do, in trout, maybe it's a little bit bigger picture of the things you have to worry about. So we started with oxides, like Jose mentioned. Hopefully we aren't feeding any of those in this room. And then sulfates were developed. Those were developed in the 1930s, allowing that metal to be bound to the ligand with an ionic bond, and that bond is weak. It was improved over the oxide sources that we had. However, it is still a weak bond. Then in the 1970s, organics were developed, and these were a very exciting development in the mineral space because it allowed for a strong covalent bond between the metal and the ligand. Additionally, hydroxides were developed in the 1990s. Got those in the ruminant space around 2012. So it's a relatively new technology compared to some of the things we've been feeding. And our hydroxychloride trace minerals also have that improved bonding structure of that covalent bond that's strong, allowing that metal to dissociate where we want it to so it can be absorbed by the animals, like we learned about this morning. So sulfates and hydroxys are similar because they are inorganic. They do not contain carbon or nitrogen in their structure, but that's the only place that the similarities are. Hydroxys, and in particular, IntelliBond, is an improved trace mineral source because it has that strong covalent bond, again, allowing that to dissociate at the point that we want it to. I don't have the research today, but we have a lot of great information about how those weak ionic bonds that we see in sulfates actually dissociate in the feed as soon as they hit moisture. So whether that's adding water or outside today, we have moisture in the air, right? So Jose also showed this slide. He stole all my slides today. I apologize, but it's a good thing to review because we have learned a lot of information so far. So this was a recent meta-analysis that was done out of Barry Bradford's lab, looking at how IntelliBond, hydroxytrace mineral, versus sulfate affects NDF digestibility. And we have a couple of different methods that are shown on this slide throughout the different trials that we've completed. And I do also want to highlight that these supplemental trace mineral levels, most of these studies were done prior to the new NASEM that came out in 2021. So these are a little bit higher levels than hopefully some of us are feeding today. But the meta-analysis found that feeding IntelliBond trace minerals versus the sulfate-based trace mineral treatment improved NDF digestibility by 1.7 percentage points. Again, compared to those sulfate-based trace mineral programs. Additionally, like I mentioned, we have in situ marker and total collection. Total collection is really thought of as the gold standard, particularly for small differences we see, such as trace minerals. And with this, we actually see 2.8 percentage point improvement in NDF digestibility from the IntelliBond fed treatment compared to the sulfate fed treatment. So definitely large improvement in the digestibility of that feedstuffs, leading us into the dairy NutriVision, the improved sustainability. If they can get more out of that, better. So this was also kind of mentioned in JB's talk this morning, but this graph shows the different Fermentrix trials that we've done up until the most recent one that I'll just go over briefly. But we're looking at the basal mineral from the diet, so average basal of those different experiments, And then we have the supplemental, which is the mineral added by Intellibond or sulfates, depending on what the experiment was. And then we have the total diet. So all the mineral that was consumed in the feed, and that's what we're getting, or those are the levels that are being recommended by the NASEM, which is what we most commonly use in the US. So the aim of our studies, I have 5-ish different experiments to show you guys today. The aim of those studies first was to evaluate the differences in trace minerals, sources on 48-hour in vitro fermentation from all minerals in combination, so copper, zinc, and manganese, the 3 Intellibond minerals that we have. Sulfates, zinc, and manganese separately, because we know copper has antimicrobial effects. We use copper in our foot baths, a copper sulfate that can easily dissociate when it's in water, and that copper has antimicrobial effects. So we wanted to look at how do zinc and manganese also affect the rumen environment? Are they as detrimental as free copper in the rumen or less so? So we looked at those as well. And then in our most recent trial, we looked at the effects on methane. If there is some sort of antimicrobial effect, is it antimethanogenic as well? And how is that affecting the rumen environment? So to accomplish this, we have a couple of different trials. The first one, all Intellibonds versus sulfate, so inclusion of copper, zinc, and manganese, comparing sulfates to Intellibond. So again, that's where we have that weak ionic bond with the sulfate, the strong covalent bond with Intellibond. Trial 2, looking at manganese sources alone, inclusion of manganese from manganese oxide, manganese sulfate, Optimin, and Intellibond. Trial 3, zinc sources. So we started increasing the number of treatments that we had, increasing the number of data points, have 7 different sources of zinc, control without additional trace mineral, zinc oxide, zinc sulfate, Intellibond zinc, Vistor zinc, Avela zinc, and Mintrix zinc. And then expanded manganese sources as well. So we had the first trial on manganese, is this affecting the rumen environment? And then we had a subsequent trial looking at all different types, because there's not just sulfates and Intellibond on the market, although we would like there to be. There are a lot of other competitors out there as well. So we looked at 7 different sources of manganese, control without additional trace metals, manganese oxide, sulfate, Intellibond, Vistor, Avela, and Mintrix again. And in our most recent Fermentrix trial, we wanted to understand how it affects fermentation characteristics, including methane. So that data had not been pulled from the system previously. So we basically had to repeat the trials in order to gather that data. So for that, we again did a couple of experiments that I all lumped into trial 5. The methane experiment of Intellibond, the straights, and in combination, so copper, zinc, and manganese, and then a combination of copper, zinc, and manganese for Intellibond versus sulfate. The other hydroxy trace mineral treatment, so we are not the only hydroxychloride on the market, but how do we perform in an in vitro system in the rumen environment? So looking at control, no additional trace mineral, plus inclusion of copper, zinc, and manganese in combination of sulfates, Intellibond, Nutrilock, Fibro, SAM, Orpha, and glycinates. So some of the European big competitors as well. And then last but not least, zinc sources. So one of the things we've done in the US is actually test competitor material, mostly for the other hydroxys that are on the market. And what we've seen, particularly for the zinc products, is that there's a lot of other things in that sample other than zinc hydroxychloride. Whereas Intellibond is guaranteed at 95% hydroxychloride, these other products don't have the oversight that we do. They don't have the testing that we do and can't guarantee the hydroxychloride levels are that high. So we wanted to look at what contribution is some of these other things in our other hydroxy samples contributing to the rumen environment. So we looked at zinc oxide at a normal level, zinc sulfate, Intellibond zinc, oxide zinc at a level of that was found in the lowest contaminated hydroxy sample, a level of zinc oxide found the highest amount of zinc oxide in a hydroxy sample. And then also a regular dose of, so those were primarily found in the ChemLock competitive samples. We also took a sample of that ChemLock sample that had low levels of zinc oxide and a ChemLock sample that had high levels of zinc oxide. Hopefully that was understood. I'll go over it again when we get to the results. So what are we looking for when we get this Fermentrix data? This is an output that we typically get from Fermentrix, which is the in vitro system that we worked with. They're based up in Canada. Fermentrix is just the name of the company. And this is the output that they get. So things we are most interested in are microbial biomass production. They use that as a predictor for milk production in their equation that they've developed from their in vitro system, as well as organic matter disappearance. We get a lot of variability in this system for NDF digestibility. So we're using organic matter disappearance as a proxy for NDF digestibility. So how did we do this? We ground TMR samples to 400 milligrams, ground to 6 millimolar, 400 milligrams total. And that was put in Ancom bags, collected rumen fluid that was then filtered and bathed in CO2. We put that in glass fermentation vessels, 80% KSU buffer, Kansas State University, and 20% rumen fluid. And then the mineral treatments were added with that rumen fluid. Those fermentation bottles were placed in a reciprocating water bath at for 48 hours at 39.5 degrees Celsius. So I mentioned what the trial setup kind of looks like. This is a graphical or chart table depiction of what the treatments were and what the levels were. So I mentioned that we had the new NASEM come out with different levels in 2021. So that was reflected in trials 3 through 5. That's why trials 1 and 2 have different levels of metals. Our statistics, thanks to Gavin, ran all the stats for me on this, analyzed with proc mixed, completely randomized design, bottles the experimental unit. Significance was determined at p less than 0.05. So measurements, I realize now this probably should have gone at the beginning, but Fermentrix is a system, a commercial lab that anybody can send feed samples to, what have you, to understand how that's going to affect in vitro fermentation. Can be used in the field, allows nutritionists to figure out how to adjust their rations. Again, the things we're most interested in, organic matter disappearance, apparent microbial biomass production, and then only in experiment 5, because that was the first time we looked at that and had access to that data, was methane over that organic matter disappearance as a proxy for methane yield. So our first trial, all Intellibond versus sulfates, again, copper, zinc, and manganese in combination compared to Intellibond. So there's no straights in this one. You'll notice we have organic matter disappearance and treatment on the horizontal axis, control sulfate mineral Intellibond. We do see a significant difference in organic matter disappearance from the Intellibond versus the sulfate-based trace mineral treatment. We saw this in the meta-analysis of NDF digestibility. We anticipated this result, but we can confirm that through that in vitro system. For apparent microbial biomass production, we also know that copper, like I mentioned, has a detrimental effect on microbes. It's antimicrobial. Well, it also has the same effect in the in vitro system. So our apparent microbial biomass is significantly different between the Intellibond and the sulfate-based trace mineral treatment. Again, Fermentrix has developed an equation to predict milk production, and that is largely determined by microbial biomass production. So if we're getting more microbial biomass, we should be getting more milk from these animals, which was also shown in the Florida trial we went over. So overall, in trial 1, looking at all of Intellibond combination versus sulfates, our first foray into fermentrix, we saw that Intellibond was an improved trace mineral source, didn't negatively impact organic matter disappearance or microbial biomass production. In the second trial, we wanted to see how this impacted manganese sources. So we included manganese oxide, sulfate, optimin, and Intellibond in this one. So this is only manganese, no copper, no additional zinc. And in this trial, again, this first graph is showing apparent organic matter disappearance of our different manganese sources. We have organic matter disappearance here and our treatments across on the bottom. So again, starting to get more and more treatments, more complicated study design here. Again, we do see a significant difference between the Intellibond and the sulfate treatment. We also see a significant difference between the oxide treatment as well. Again, less commonly fed nowadays, but still important to understand how that's going to affect the rumen environment. For apparent microbial biomass production of manganese sources, we see, again, the setup is the same in this trial here, but we do see significantly more microbial biomass production, actually both from the Intellibond and the optimin treatment. So if you are feeding optimin trace minerals as well, you won't see a detrimental effect of that organic, because if you remember from the previous slide, organic and hydroxys are improved. They have that stronger covalent bond, allowing for that dissociation to happen at the targeted point that we want it to happen. So in conclusion, for trial 2, improved manganese sources, Intellibond and optimin, did not negatively affect organic matter disappearance, whereas the sulfate and the oxides did, which we anticipated. Improved manganese sources also had higher microbial biomass production compared to sulfate. We know copper sulfate is bad. Also, manganese sulfate is bad, right? Our third trial, looking at zinc sources, and these are expanded zinc sources. So we had our control with no additional trace mineral. Again, these are only additional zinc. So we had Intellibond zinc, sulfate, oxide zinc, Vistor, Avela, and Mintrex for some other products that are on the market today, particularly for the US for these trials. Similar setup to the previous study. However, in this zinc sources trial and the expanded manganese sources trial that I'll go over next, we are comparing these against the Intellibond. So that's why we have Intellibond on the left over here. There's a line. So all of these other treatments are in comparison to Intellibond. So how did they affect the rumen environment again in comparison to Intellibond? How Intellibond affected the rumen environment? So Intellibond, you can see the first one here, against the control. Actually, all treatments in this zinc sources trial, Intellibond zinc had significantly more organic matter disappearance than any of the other treatments in this trial, including the sulfate, which again we expected from the manganese trial and from what we know about sulfate-based trace minerals. Also saw significantly more organic matter disappearance from the Intellibond treatment compared to the other competitive products on the market. For microbial biomass production, again, that proxy for milk yield that they use in the fermentrix equation, we do see significantly less microbial biomass production from the other treatments, excluding the zinc oxide treatment. So in comparison to Intellibond zinc, zinc oxide didn't have as much of an effect. So in conclusion, for the expanded zinc sources trial, Intellibond zinc did not negatively affect organic matter disappearance, whereas all other treatments significantly reduced organic matter disappearance. We see a similar result with the microbial biomass production of Intellibond improving apparent microbial biomass production compared to the other treatments. So trial 4, similar to trial 3, these are expanded sources, but now we're looking at manganese and some of the different sources that are on the market. So in this one, we had a control with no additional trace mineral, a manganese oxide, manganese sulfate, and Telebond manganese, Vistor, Avela, and Mintrex. So again, some of those other competitors that are pretty heavy in the market, at least in the US. And a similar setup to the last experiment, these were run concurrently. So we have a similar experimental design for these two, but we do have the Telebond manganese on the left, and then we are comparing all other treatments to the Telebond manganese. So no significant difference between Telebond manganese and control. However, significantly less microbial biomass production from the other treatments compared to the Telebond manganese. For apparent organic matter disappearance, we don't see many significant differences other than manganese oxide. Could potentially be due to too tight of bonds in the manganese oxide that there's no dissociation at all, and potential dissociation, partial dissociation in some of the other products that are reducing organic matter disappearance in the system. So for the expanded manganese sources, Telebond manganese improved microbial biomass production compared to other treatments, and it did not negatively affect organic matter disappearance compared to the control. And the really complicated trial that has 3 different experiments in it. So this is the most recent one we've done. We were interested in how methane is impacted in this system. And to do that, we wanted the methane data from basically all of the experiments that we've seen so far, but in combination, because we know copper impacts the rumen environment. The 2 previous studies have shown us that zinc and manganese alone also impact the rumen environment. So how do these affect methane? So our first experiment was just Telebond versus sulfates. So we have all of the straights, copper, zinc, and manganese, all of those in combination for the Telebond and sulfate trace minerals. For the second one, we wanted to look at other hydroxy trace minerals. So how do different products on the market affect methane production as well? Because we know some of these other products on the market affect fermentation, but we didn't look at methane previously. So for this one, we had copper, zinc, and manganese in combination with a control, no additional trace mineral, sulfate treatment, Telebond treatment, Nutrilock, Chemlock, Fibro, Vistor, SAM, Orpha, and EcoTrace, which are, I know, prevalent in this market as well. And then last but not least, experiments 3, those were the zinc sources. So again, I mentioned some of the other products on the market have pretty high levels of zinc oxide and also have varying levels of zinc oxide. So how does the lowest level of a zinc oxide, just the oxide, affect the treatment or the in vitro fermentation? How does that in the mineral affect fermentation? So for this one, we had a control, a zinc oxide, sulfate, Telebond zinc, oxide zinc at the low levels found in other samples on the market, at the high levels found in other samples on the market, and then those 2 samples that we found with low oxides and high oxides. So in this experiment, we did not have full control over the study design. So we do actually have 2 separate runs for each experiment. So, and each of those runs have their own control. So the way we've set up the results of this one is this black line here on both of the graphs is going to be your control, and the bars reflect the treatment's deviation from the control, whether that's a positive or a negative. And all of the setup of the rest of these graphs will be the same. So for organic matter disappearance, for trial 5, experiment 1, we have sulfates on the left and Telebond on the right. You can see there is significantly less organic matter disappearance from the copper sulfate treatment, the sulfate mix, and there's a trend for more actually from the zinc sulfate treatment, which is in contrast to what we'd seen in previous experiments. And then on the right, you can see the organic matter disappearance of Telebond, again in combination We, in this one, only see a trend for more organic matter disappearance from the IntelliBond manganese, which again was different than we've seen previously. However, in this run, we did also see a lot of variability within our results. In looking at the microbial biomass production of the sulfates versus IntelliBond, you can see no significant differences here, but a trend for less microbial biomass production from the sulfate treatments and a trend for more microbial biomass production from the IntelliBond treatments. And last but not least, methane over organic matter disappearance as a proxy for that methane yield. This is the first time that we've looked at methane in the in vitro system from IntelliBond treatments. So again, on the left, we have sulfate treatments, and on the right, we have our IntelliBond treatments. And we do see a trend for more methane yield from the copper sulfate and the sulfate mix. And we do actually see significantly less methane from all of the straits of IntelliBond, which was a very interesting result considering how we impact microbial biomass production. Looking at the second experiment, so again, this was the other hydroxy trace mineral. So how do some of these other hydroxy trace minerals on the market affect that in vitro fermentation system, particularly for methane? We have, for the first run, Chemlock did have significantly more organic matter disappearance, no other significant differences in that trial. And then in the second run, we have significantly less organic matter disappearance from the EcoTrace treatment and a trend for less from the Orpha and the SAM Nutrition. For microbial biomass production, we see significantly less microbial biomass production from the Chemlock Vistor treatments, a trend for more from the IntelliBond, which is consistent with what we've seen in previous runs. And then for the second run, we see a trend for less microbial biomass production from the EcoTrace, significantly less from the Orpha and SAM Nutrition treatments. And then for methane over organic matter disappearance or methane yield, we see significantly less from the Chemlock, IntelliBond, and Vistor treatments, and a trend for more from the EcoTrace treatment. And then our third experiment in this run, looking at how zinc oxide affects that system, we see no significant differences for organic matter disappearance from the first run. From the second run, we do see significantly more organic matter disappearance from the Chemlock high zinc. No other significant differences. And then looking at microbial biomass production, see significant differences for all the treatments in the first run and a trend for more microbial biomass production from the IntelliBond zinc in the second run, which again is consistent with what we've seen in previous fermentic trials. And for methane over organic matter disappearance, we see significantly more methane from the high oxide treatment, a trend for the sulfate zinc, and no other significant differences here. So in conclusion of trials 1 through 4, so before the methane data, a combination of IntelliBond trace minerals did not inhibit microbial growth compared to some of the other treatments. IntelliBond manganese increased organic matter disappearance in the second trial, but not in the expanded. IntelliBond manganese and zinc increased apparent microbial biomass relative to other zinc and manganese sources, and zinc did not negatively affect organic matter disappearance, whereas all other treatments did. So overall, IntelliBond is an improved trace mineral source, increasing in vitro fermentation relative to other copper, zinc, and manganese sources. And then for our methane trial, experiment 1 showed the mix reduced apparent organic matter disappearance, whereas the IntelliBond manganese improved organic matter disappearance. Nutrilock Chemlock increased OMD, and experiment 3 showed that all sulfate and oxide sources reduced organic matter disappearance, whereas IntelliBond tended to improve or produce more. So again, parent microbial biomass production is the main driver for milk production in the fermentric system. So we do see more apparent, microbial biomass production from the IntelliBond treatment compared to the other sources. So with that, I thank you and happy to answer questions on the panel.